Welcome to Veranda IAS. The topic is the shifting of the pressure and the wind belts of the world. So, the learning objective would be to explain the cause of the shifting of the pressure belts and also how these pressure belts shift. Now, you have seen this planetary winds that we have discussed in the previous learning units. So, how are these planetary winds formed? See, the air over the equator will be rising. When the air is rising in the equator or equatorial region, 0 to 10 degrees north and 0 to 5 degrees south, so we will be having a low pressure. A low pressure is created over the equator, and in the upper atmosphere you will be having high pressure. So, from this high pressure, the air wants to move towards the poles. Because of the Coriolis deflection, it will be sinking in 30 to 35 subtropical region. So, near 30-35 you will be having the sinking air. So, because of the sinking air you will be having high pressure. So, from this high pressure one of the branches will be moving towards the poles, but this branch which is moving towards the poles will come across the polar easterlies. So, they will be colliding with each other, frontal action is created, and whatever air which is coming in this region of 55 to 65 degree north, so that will be lifted up again. So, therefore, between 55 to 65 you will be having the subpolar low pressure belt. So, you know how equatorial low pressure belt is created, you know how subtropical high pressure belt is created, you know how subpolar low pressure belt is created. And of course, in the polar regions you will be having high pressure. So, this we have done couple of times. So, if you are not clear with this, please go to the previous learning units and understand how this planetary wind system works. Now, because of the atmospheric circulation, the planetary winds are created. Now, let us see the shift in the pressure belts. So, the pressure belts differ in the way they are formed. The equatorial low and polar high are formed thermally, and subtropical high pressure belt, subpolar low pressure belt are formed dynamically. So, you can see here how the thermal belts and dynamic belts have been formed. So, here thermal high pressure, you have this high pressure. So, why this high pressure has been created? Because of extremely low temperatures. Because of extreme low temperatures you have sinking air. Same goes to the southern hemisphere is not different. Then thermal low at the equator. Why this is created? Because of convection, because of rising air, because of currents. Since it is created because of heating, it is called as the thermal. Now, this is dynamic in nature. That means it is not created because of thermal reasons. So, what is the reason for the creation? Because you have this sinking air. So, generally high pressure should be because of low temperatures. But do you think in this region, in Sahara, you have this low pressure? No. So, despite having high temperature in this region, you have high pressure. Ideally, you should be having low pressure. What is the reason here? The reason is dynamic, the reason is not thermal. It is created because of the sinking air. So, that is why it is dynamic in nature. Now, let us take this. So, this is between 55 to 65 degree north, right. It is near to the polar region, because after 63.5 polar belt will start. Now, do you think in this region you will be having high temperature? No. Generally, wherever you have this high temperature, you will be having low pressure. But in this region, you have this low pressure. And this low pressure is not because of thermal reasons. It is because the frontal action. So, whatever air is coming in here, it is getting uplifted. a low pressure is created. That's why it is dynamic in nature. Now let's see the shifting here. So this diagram I will explain more clearly. So I will be taking 3 earths almost on the same plane. So you will get an idea of the movement of ITCZ. So I will be taking the same reference lines here. So the equator, this is the equator, this is the equator, this is the equator, same reference line. And then you have this subtropics. So this is the subtropics here in the northern hemisphere, and this is the subtropics in the southern hemisphere. Here also you have this subtropics, here also you have this subtropics. Similarly, these are the subtropical regions. I hope all of them look in the same line. Now during the equinox, equinox means the sun is over the equator. This is equinox. So this happens in the month of March and in the month of September. So the sun is over the equator here. When the sun is over the equator, the ITCZ, the low pressure zone, is also on the equator. So this will be calling it as ITCZ also, that is Intertropical Convergence Zone, because this is the zone where the trade winds will be converging. So trade winds will be coming from here 30, 35. So trade winds get converged here. So this is the normal scenario, right? But during summers, now after March, the June will come. So during the June, what is the apparent movement of the sun? It is shifting 23.5 north. Earlier sun was over the equator. That's why the high insolation zone and the ITCZ will be lying over the equator. Now sun has shifted a bit north, so ITCZ will also shift. So I am not differentiating the movement of the sun on water and on land. I am not differentiating that. I don't want to make your life complicated. Let's assume everything is land. So the ITCZ will shift at least 25 degrees. In the North Indian plains, in the Indian subcontinent, it will be shifting 25 degrees because of the presence of land. So I'll assume it's land, and then I'll be shifting the ITCZ. So the shift of the ITCZ is here, 25 degrees north, assuming that everything is land. Now when ITCZ is shifted, the trade wind belt system will also shift. Okay, so instead of starting from here, so they will start bit behind. The trade winds are shifting bit north. Instead of starting from 30, 35, they may start at 40 now. So this is 40. They start from here. In the southern hemisphere, instead of starting from 30, 35, they will be starting from 25, 30. So they will be shifting here a bit. And they want to move towards ITZZ. But after crossing the equator, they have to change the direction, because in the northern hemisphere, the deflection is towards right. So deflection will take place like this. So this is how the shifting of the ITCZ will take place. Along with the shift in ITCZ, the wind belts will also shift. So the effect of the shift is manifested in terms of monsoonal climate in India, which we will see later. Similarly, in the southern hemisphere, when they have summers, the ITCZ will shift south near to about 20 degrees, because in south you don't have much of land. So instead of starting from 30, 35, they will be starting from 20, 25. So they will be moving towards the equator. They actually wants to move towards ITCZ, but after equator they will be changing the direction So, this modified trade winds in the southern hemisphere after the turn will also create a monsoonal type of climate in Brazil, in eastern part of Africa, Mozambique channel, and also in Australia. Now, here they will be starting a bit behind. So, they will be starting somewhere near about 40. So, this is the shift of the ITCZ and the associated change in the wind pattern. So, the same thing has been depicted here. I hope you have noted this down. If you haven't understood this, please repeat that section again. The same thing has been represented here in terms of this vertical cross section. So, do the same thing vertically, so you will get this kind of a pattern. Next, shifting of the trade winds. So, I have already explained how the shift of the trade wind happens. So, when the ITCZ is moving a bit north above the equator, so the trade winds while they cross the equator will be changing the direction. So, this is where you will have this India. So, this is where India is there. So, these are nothing but the southwest monsoons. So, the modified trade winds become the southwest monsoons. The shift in the pressure belts, the wind systems, for example, shift of the trade winds can be depicted as follows, which you have seen already. So, these modified trade winds become the monsoons. Now, let us see the shift in the westerlies. So, this is very important to understand the Mediterranean type of climate. Now, I will be drawing the earth again here. I will be drawing two figures. I will be making them a bit bigger. So, inside you will be having the equator. This is the equator, and I will be drawing the trade winds here. So, this is the trade wind belt. So, these are the trade winds. Because here the ITCZ is located over the equator. So, this is the ITCZ, this is the equinox. Now, let us assume the winters in the northern hemisphere. That means ITCZ is moving into the southern hemisphere. Now, this is the new ITCZ. It is moving about 20 degrees in the southern hemisphere. Now, what are the winds which are lying above the trade winds here? So, here you will be having westerlies. These are the westerlies. And above this westerlies, what do you have? Above this westerlies, you have this easterlies. So, these are the planetary winds, right. Now, because of the shift in the ITCZ, the trade wind belts will also shift. So, how are they shifting? So, instead of starting from here, they will start a bit here. And after crossing the equator, they will change the direction because of the Coriolis effect. And here they will be starting a bit behind because of the shift in the trade winds. So, this is a new zone of the trade winds now. I hope you can see that. Now, this region which was otherwise under the effect of the trade winds, this region was under trade winds earlier, but now this has been vacated. Someone has to occupy. So, the westerlies will be shifting a bit towards the equators. Now, this region is now under the influence of westerlies, and they form the Mediterranean type of climate, this region. So, earlier it was under the region of, under the influence of offshore trades. Now, the onshore westerlies come. So, that is why this region receives winter rainfall during, this is happening during winters. So, this region receive winter rainfall. So, anyways, okay, you will have one more diagram related to this. I hope you have understood that. So, the shifting of the westerlies in the otherwise trade wind belt gives rise to the Mediterranean type of climate. You can see it here clearly. So, these are the westerlies, this is a trade wind belt. Now, the westerlies will be moving into the trade wind belt zone. So, this is the shifting of the westerlies. So, I hope you have understood the causes of shifting of the pressure belts and the shifting of the ITZZ, shifting of the trade winds and shifting of the westerlies. So, thank you and see you in the next learning unit.